Hey guys, in this video I'll show you how to simulate a BJT amplifier circuit in LTspice, also how to get all the required plots for your analysis. So let's get started. First open your LTspice, create a new schematic. Before we get started and get the plots, I would suggest you change some setting in LTspice. That would make your plots looks nicer, and it would be nicer in your report as well. So go to tools, color preference, and then waveform, select background, and then make it white. So slide this and make this all to 255. That will make the background to white. Select axis nest and make it black, so make all red, green, blue to 0. Click OK, and that's pretty much about it. Now let's get started with building the circuit. Click F2 to bring out this component table. Search for, so we want NPN transistor, so just search NPN, it will bring up the transistor. Click place, and it will place it. Click escape to go back to the original mode. Click F2 again. Now we need the resistor, place it. You can also click on R and it will also pull up your resistor. You can also click C to pull up, to take a capacitor, place it, and then you can click G to place a ground, and click V to bring up a voltage source. Okay, now we can rearrange it to get the circuit. So I'll fast forward it. Now that we have built our circuit, we will edit our elements to our desired values. Right, so right click on each of the elements and start inputting the values. You have to calculate the values. I have already calculated the values for this circuit, so I'll just go ahead and enter them. Also, for the transistor, you can pick a specific type of transistor. So right click on the transistor, pick a new transistor, and then select your desired transistor. I'll go with this one. For the capacitor, alright, now that we have our circuit and our values, we can run some analysis to get our plots. Let's see, let's set our input voltage. So right click on it, click advance. We want a sinusoidal input, so click on sine. Set our voltage DC offset to 0, amplitude to, let's do 10 millivolt, frequency at 10 kilohertz, and click OK. Now click on simulation, configure analysis, and we'll do a transient analysis. So for the stop time, since our frequency is 10 kilohertz, and if you want a 5 cycles in your plot, so you can do a calculation. So 5 divided by 10 kilohertz, right? So that's our period. That would be 1 over 10k, 1 over frequency gives you a period, right? So on 5 periods, so 5 times that period will give you 5 complete cycle. Okay, so that is about half a millisecond, right? So click on OK, place it here. Now click run this button, and then it will run it. Okay, you can click on this to maximize. Now if you want your see your input, so if you hover over your wire, it will bring up a probe. Just click on it, and if we go to your plot, it will show up your input voltage right here. So VNO4, that's if you go back to your plot and hover over it, you can see it at the bottom left corner, your node number, which is just say VN004. So that's your node number. What you can do is right click on it if you want to specify the name. Create label net, and then here you can set it as input and name it as VN. Click OK, place it, and then you can do the same for your output. Right click on it, label net, and then that's our output, right? So name it Vout, click OK, and then place it here. Now we have to connect it, right? So click on the wire and then connect them. Okay, now if you want to know the voltage at each node, you can also right click on it and then place data label, click on it, and then it will show you your voltage there. So we can do it for all our base, emitter, and collector. So if you run it, it will show you your voltage here. So our base is at base voltage is 1.65 volt. This is our collector voltage and our emitter voltage. Okay, let's go back to our graph. Now in here you can see we only want V in, right? So what you can do, you can right click on the other one and you can say delete this trace, and it will delete it. And then you can right click on the graph and then say zoom to fit, it will zoom back in. Right, let's see what our output voltage is. So hover your probe over our output, go back to the drawing, and so this is the green plot, that's our output V out. So our output goes from negative 2.5 to 1.9 volt peak to peak. For our 10 millivolt input voltage, we're getting about 4.5 volt output. Also keep in mind that the 10 millivolt input, it is the amplitude, so peak to peak would be 20 millivolt, right? So for 20 millivolt input voltage, we're getting 4.5 volt output. This would be a transient analysis for 10 millivolt input voltage. Right, you can also change it to see your output response. So let's change our input voltage to 20 millivolt. Click OK and then run it again. Maximize it. Alright, so this is your output. This green wave is your output for 20 millivolt input. So that goes from negative 5.7 to positive 3.3 volt peak to peak. Okay, now you can change the input voltage one more time to observe our clipping input voltage. So let's set it to 35 millivolt, run it, and you can see so your output voltage is getting clipped, so it's flat at the bottom, right? So that means it's clipping. All right, so let's do AC analysis. Let's find the gain of our circuit. So click on simulation. So click on simulation, configure analysis and go to AC analysis, and we want our circuit in decibel, our plot in decibel. So select decade. Let's number of points per decade. Let's do 5k, not 15, 5k. Start frequency, let's set it at 100 and stop frequency to 10 megahertz. So just type 10 mega and that'll do it. Place it here. Now we have to, in order to get the gain, we have to change our input voltage. So right click on the VN and then set our functions to be none, and then on the right side, small signal AC analysis, set your AC amplitude to 1. Click OK. Alright, now run it and then enlarge it. So our gain is V out over V in, right? So what you can do is right click on the plot and then set add trace. So we want V out, so click on V out, then divide by V in, right? So click OK, and this will plot your gain. So this is our gain. Now if you only want, it also gives your phase, right? So if you only want your gain in magnitude, what you can do is go to the right side and then right click on it and then see don't plot the phase, and this will take away your phase. And your gain is given in decibel dB. If you want it in magnitude or linear scale, right click on it, set it to linear, click OK, and this will give you your gain in linear scale. So right now your gain is, if you hover over your cursor here, it will show up at the bottom left corner. So we want our gains, which is Y, right, which is 220, so pretty good gain. Okay, so if you want your higher and lower F negative 3 dB gain, what you can do is right click on it and then choose place a cursor, and then it will show up in a window. Let's place another cursor, drag it until the difference, this is the difference in here, until the difference becomes 3 dB, right? Doesn't quite goes that far. If that happens, what you can do is right click on the x-axis. So we need to increase it, right? So let's make it 100 megahertz. Click OK and then click zoom to fit. It does not quite do it. Okay, so in that case, what you can do is close this plot, right, and then go to a simulation, configure analysis, AC analysis. Now in here we can set it to 100 megahertz. Click OK. Now run it again, enlarge it. We'll do add trace, V out over V in. Click OK. Now we can see it goes to 100 megahertz, right? So let's delete our phase. Now if we want to find our upper and lower 3 dB frequency, what you can do is right click on it, place a cursor, and then right click again to place another cursor. Now move it until you see the magnitude, so the difference is 3 dB, right? So just a little bit more right there. So this is our upper 3 dB frequency, right, so which is 12.7 megahertz. In order to find the lower 3 dB frequency, we'll do the same in the other direction until it is, we see the difference to be 3 dB. Let's see a little bit more. There you go. So lower 3 dB frequency is this one, 248 hertz. Right, if you only want your phase, your gain phase in with frequency, right click on it and then right click on this axis, enable this, click OK, and you can delete your gain. So this is your phase with respect to frequency. Alright, now we'll do input and output impedance. So to find the input impedance, we'll run our simulation and do a AC analysis, set everything as before for our gain analysis that we did. Click OK and then run the simulation, enlarge it, add trace. So input impedance is just Ohm's law, right, which is voltage over the current. So V in over IV in. Click OK, and this will plot your input impedance and its phase. So we don't want the phase, so you can right click on the axis and then don't plot the phase. So now this will give your input impedance. It gives it in decibel, so in order to change it, you can right click on the axis and then set it to linear. Click OK, and then this will give your input impedance in linear scale. Alright, so we are operating, our optimal operating point is, let's choose it at 10 kilohertz. So you can place a cursor and then put it to 10 hertz, and then in this window it will give you your input resistances. So that's about 921 ohm. Okay, so let's do output impedance. So you can close this graph. For output impedance, it's a little bit different. So what you want to do is take this source out, place it here, take this load resistance out, and then connect your capacitor to the source. We also need to place a ground here, so we'll do that. Connect it. Alright, now we're ready. Run it. So, and all of the other your source will still remain the same. Function is known, and small signal AC analysis at 1. Okay, run the simulation, enlarge the window, add trace. Where's the current? Still IV in. Okay, run the simulation, enlarge the window, click on add trace. It will still be V in over IV in. Click OK. That will plot your output resistance, output impedance, and its phase angle. So if you don't want the phase angle, you can right click on the axis, don't plot the phase, and then it still shows in decibel scale. So you can right click on it and set it to linear, and that will give your output impedance in linear scale. So we want to find our output impedance at 10 kilohertz. So we'll do place a cursor, looking up the window, and then move our cursor to 10 kilohertz, about 10 kilohertz. It does not has to be exactly at 10 kilohertz, but somewhat close to it. So this is your output impedance at 1.8 kilo ohm. All right. I can go back to the normal. All right, that's it. Thanks for watching. Let me know if you have any question in the comment. Bye.